Hey everyone, and thank you for joining me today on the CTO Talking Kubernetes to me and my fellow CTOs. In this session, I'm going to talk about our journey to Kubernetes and specifically the journey that led us to the Kubernetes gold mine, which is the Kubernetes audit log. From a company standpoint and myself, I am from Tel Aviv. I try to enjoy skateboarding as much as I can in my spare time. The recent events with Corona are making this a little bit more harder. And by way of professional background, I spent most of my career as a kernel developer, started at Checkpoint, building firewalls, VPNs, and network security devices, and then moved to a startup that focused on security for the virtualized data center, building distributed firewalls on the VMware ESX kernel. And at some point, I got an upgrade to the cloud native world with Kubernetes containers and anything that happens in between. I presently the CTO of Alcide, the company which is purely focused on end-to-end security for Kubernetes and service mesh, and pretty much helping customers deal with the many challenges that Kubernetes brings into the table. So as I mentioned, I'm going to share with you about our journey since the foundation of the company and all the way to the point in time where we decided to develop Alcide K8s, which is our Kubernetes forensics analysis products, and basically help us to kind of share insights to security professionals and identify threats within the cluster. And we'll dive deep into that as we move along. So when the company started, we had many challenges out of the gate. We knew that we want to build container security, and Kubernetes was really early stage during this time. So out of the gate, we were running on two different cloud providers. We started with GCP and AWS, and Azure is something that happened down the road. We are operating multiple cloud accounts as a general practice. We have development accounts and we have production accounts. And we are operating a large number of Kubernetes clusters across all of these accounts. Part of the idea that we are running on multiple cloud providers and building infrastructure that should scale over time, we really want to kind of focus or build our platform on top of Kubernetes, which means that we didn't want to have any cloud specific components that were tying us to a specific cloud provider, under the notion that we will be able to kind of scale and expand to different cloud providers and even running on fully hosted and on-prem Kubernetes clusters. So running our stateful workloads, which are primarily Kafka, that serves as our data platform or kind of the data backbone, Cassandra, which is our scalable data store, Mongo and etcd, are all running inside our Kubernetes clusters. And we did have a lot of architectural changes to make the cluster work as if those components are running pretty much as a single component running on VM. So we really had to kind of help the Kubernetes scheduler to kind of build or shard the cluster in a way that we can really scale those components in the way that they were designed to scale. Security was a top concern from day one. We knew that we are building a company that delivers security solution. So for that purpose, we want to make sure that everything from day one is kind of running with the best security practices that we can have. Naturally, we always kind of need to fit the security controls to the size of the company, the requirements, and not affecting, of course, the productivity of what we were doing. And the fifth challenge that we had as part of the product that we delivered, we are running security agents inside our customers' premise, which means that we have security agents that are connecting or are always connected to our cloud service. And this is something that delivers or kind of have an intrinsic challenges as far as building a cloud service, monitoring it, and all the challenges around that. If we try to look the lifeline of the company since the foundation of the company and all the way to today, we can see that some of the security features and the main ones that we can see here that are really important didn't even exist when we really started our journey. So for example, when we had slideware, we didn't have even a single line of code. This was pretty much around the time of Kubernetes first beta. And when we just did our seed funding, Ingress, for example, was introduced into Kubernetes. If I recall correctly, this was version 1.2. And then luckily for us, we had our first and foremost kind of patient zero, I like to call him, join us to the engineering team. This was in September. And from this point onward, we can see, for example, that the Istio was kind of introduced to the world, very early stage, very new. Nobody actually knew what exactly we can do with that, other than the fact that it made a lot of sense to build systems using the notions and concept that Istio has promised to deliver. And one of the main challenges that we had seen, RBAC didn't exist all the way to the point of version 1.8, and network policies, which is pretty much the bread and butter of what Alcide actually does, which is the runtime security, became GA at version 1.8, which was around summer 2017. Alcide was a launch partner for K8s during that summer, and in KubeCon during December 2017, we kind of emerged out of stealth with our core offering, which was microservice firewall, deep and advanced network security controls around detecting DNS tunneling, and many deep security features, which I will touch briefly later in this presentation. And as we moved along and kind of matured our journey with Kubernetes, and Kubernetes by itself matured, we released more components to our security platform, which were addressing different challenges or new challenges that we saw with our customers. So for example, Alcide Advisor was introduced in KubeCon in Barcelona in June 2019, which primarily focused on helping customers deal with all the security related configuration of Kubernetes. So hardening of pods, identifying secrets in the wrong places, making sure, for example, that we can whitelist which ingress controllers exist in the cluster or load balancer services. So all of those moving parts that teams need to take care of when they're building Kubernetes, but doesn't necessarily have the know-how to address them. And I think that the eye-opening experience that we had with Kubernetes was mainly around the inception and building K8s, which is our AI-driven forensics analysis for the Kubernetes audit log. As you all probably know and aware of, our cloud provider accounts has audit trails. So for example, in AWS, we have CloudTrail that captures every API invocation made by human users or access from the Cloud Console. So effectively, we have in Kubernetes the very same mechanism that tracks those events. And we pretty much saw things that we never saw with our other components in the system that basically helped us to understand more the security challenges that we see both as a user of Kubernetes, but at the very same time as a company that built a solution for Kubernetes to secure Kubernetes environments. And this is where we are at today. The day one and day two challenges that we really had as a company were mainly around, since day one, we didn't have much in our system, but we built mutual TLS between all the moving parts in the system. We knew from the get-go that running agents remotely on customer environment will require to have encryption, and anything that in flight must be encrypted. We really understood that we must have an end-to-end tenant isolation as far as delivering a scalable cloud service. We didn't have that in day one, but this is something that we, over time, kind of shifted or evolved our platform to deliver those. One of the other challenges that we really had with remote security agents is, first of all, monitoring our cloud environment. I mean, operating and running a large number of Kubernetes clusters by itself is a real challenge. And simply just by monitoring perspective, making sure that you have all the monitoring controls and all the monitoring alarms and metrics and everything around that in place is something that was critical for us to even understand that we are actually running healthy clusters and that the environments are healthy. And I will be honest and say that this is an everlasting and ongoing effort to kind of expand and get more insights and get to the insights faster and having mitigations around issues that we have with the system. And this is a constant battle and effort to improve those systems, as well as monitoring the remote agents. I mean, what exactly tells us the story if an agent is not working in a POC environment or in a customer environment? So all of these mechanisms were built into the platform at a very, very early stage of our journey with Kubernetes. And as I mentioned, we are still working on improving and enhancing those capabilities. From an operational standpoint, given the fact that we are running on multiple cloud accounts and multiple Kubernetes clusters, we did want to have the systems, the monitoring systems, accessible to engineering, which can be developers to troubleshoot issues or debug issues, as well as the DevOps team that are basically operating the health of the system. So out of the gate, we did expose cluster monitoring applications by leveraging two-factor authentication and proxy that pretty much enables us to kind of plug and export those applications without deploying complicated VPN into our day-to-day practices. It wasn't a trivial effort, but it was definitely something that paid off as far as our operational challenges when it comes to productivity. Scale was always and still an issue and a challenge, and this is something that we are constantly working on improving. And given the fact that we are running Kubernetes inside, we are running our stateful workloads inside Kubernetes, is something that we kind of have to take care of in a special way, because this is not necessarily the natural way for building or operating these type of components. And this is something that definitely kind of took toll on our engineering sleeping hours. And again, this is something that requires a constant effort to make sure that the systems are running, available, and scalable. I will say that choosing, for example, Kafka and Cassandra as a scalable data backbones for both the streaming the data as well as the storing the data is something that really paid off in many instances along the journey, despite the fact that these are not necessarily kind of easy to operate or trivial to operate components. So if we look at a day in a life in a very small subset of our environment, you can really see that, for example, customer environment will have normally our runtime agents deployed as daemon sets. We have the component that monitors the Kubernetes API server for inventory and scanning the configuration, runs as a single pod inside the cluster. It has the ability to function as an admission controller, completely policy driven. And all the audit logs are exported to the cloud provider specific mechanisms. So we are leveraging the managed Kubernetes services across all the different 3 cloud providers, and we are exporting or leveraging the default mechanisms that those managed services help us to deliver. And from that perspective, we are monitoring the health of the cluster and the security of the cluster by leveraging K8s from one single security operations cluster that basically tells us the story about the health of the security health of the other clusters. And we will dive deeper on what exact capabilities the Alcide K8 actually helps us to achieve as far as the security monitoring of the system. So between building a security product and dogfooding, the very same security product, we do have kind of firsthand experience as far as growing and appreciating and enhancing our product by becoming kind of the very first users of our own capabilities and products. And this is a good kind of test case on how it will resonate with some of our customers. And that's definitely something that, especially in the earlier days of the company, helped us to pretty much develop features over time or identify gaps over time based on the fact that we are running on top of Kubernetes as a heavy kind of users from this perspective. So let's take a quick look at what this would look like. So what you see here, and I'm not going to do like a full product overview. I want to kind of take a deeper dive on Kubernetes audit log and what should it mean to you guys. But just to give you a sense, what we basically see here is on one of our GKE development clusters, you can see how we visualize, for example, all the assets in the system. So you can see, for example, that we are right now focused on Cassandra, which is presently running on 3 VMs. We did make sure that those VMs are running exclusively the Cassandra nodes. So each and every VM is running a single node. So effectively, we can really scale out Cassandra by pretty much scaling out the node pool that this microservice is basically attached to. And we are leveraging taints and tolerations in order to make sure that certain components are really pinned to a VM pool, so we can really scale those components in separate way than the other system. We presently do not have auto scaling on our data backbone or the stateful kind of components. We are pretty much doing this manually today, and it takes really time to scale, especially those stateful components inside Kubernetes. I mean, all the fancy and exotic stories about auto scaling up and scaling down. It's not trivial to kind of do that with stateful workloads that actually carry your data. If I will unfilter this microservice, you can really see that in this specific environment, and this is kind of our demo environment, we are running multiple Kubernetes clusters that are running on multiple cloud providers, and everything around that actually helps us to kind of control and understand which assets are even running inside the system. And from the configuration standpoint, which is the Alcide advisor that I mentioned earlier, we really have a way to kind of understand across our entire Kubernetes cluster fleet the hygiene level of the clusters, if there are security drifts associated with any changes made by users. So we can really have this as something that helps us understand all the moving parts from one place. And we are pretty much leveraging what we have built to our internal needs. And as I mentioned, we are running kind of many more clusters than we are presently see in this environment. So going back to the slides, when we're looking into Kubernetes, Kubernetes has multiple components or many moving parts from an architecture standpoint. We have the control plane that pretty much takes care of, you can think about it as like the brain of the Kubernetes cluster. The scheduler is running there, which pretty much determines which workloads can run where. We have controllers, which are components that make sure that the cluster is running in accordance to the desired state. And their sole purpose is to reconcile between any difference that exists between the desired state and the actual state of the system. It's a very simple concept introduced into the Kubernetes software philosophy. And it helps us build a lot of automation and kind of cascade events in a way that help us to build really complex workflows and systems into Kubernetes itself. And once we move from the control plane, and again, the control plane is something that in managed Kubernetes services will run fully hosted inside a cloud provider. We have the worker nodes, which effectively is the backbone that actually runs our workload. So these would be containers wrapped up as pods, co-located containers, and they will be able to run based on scheduling constraints, resource availability, and anything in between. And the third component is not running inside the cluster, but represent the software supply chain. So effectively, any software that lands inside our cluster represent something that can potentially violate trust boundaries, or at least create a risk or introduce a risk inside the cluster, which means that the container image registries from which we pull images into the cluster is something that we really need to kind of understand. Which are those container image registries? Are we scanning them? Are we making sure that we are pulling clean software? So all of those moving parts is something that you can really leverage the built-in vulnerability scanners that the cloud providers provide in order to ensure some level of hygiene inside those environments. And naturally, we have users, we have automated users that can be pipelines or even service accounts that are running inside the cluster, as well as human users that needs to kind of troubleshoot issues inside the cluster. So all of those represent different actors or entities inside the cluster that may risk other components inside the cluster, and in general can create situations where they risk other players inside the environment. So when you think about securing your clusters or your environment, you really need to pick your poison. I mean, do you want to start with securing your container image registry? Or do you want to start with monitoring the runtime and understanding like what's happening on the worker nodes and the application workloads? Or whether you want to monitor the Kubernetes API server, which basically tells you a lot of information about what's happening at the cluster, but cannot cover, for example, what the application workloads are actually doing from an application transaction standpoint. So it's really a matter of prioritization and identifying which areas you would like to cover. But from an end-to-end security perspective, we really need to think about all of those moving parts as potential risks that are that exist inside your Kubernetes environments. And if you are running multiple Kubernetes clusters, naturally there is an amplification factor to this challenge. As you can see in this slide, you can pretty much see an overlay of the different Alcide components and how they cover the various trust boundaries and the various moving parts that we have inside Kubernetes. So as I mentioned, our runtime component is something that helps you deal with all the workload protection. So think about segmenting a pod that requires access to Slack or an RDS database using domain names, or if you want to detect crypto mining running inside your cluster. All of these are definitely elements that you can leverage the runtime. And the Kubernetes native controls are very basic and limited in the sense that it will give you the ability to segment east-west traffic on one hand, but managing the policies, getting the violation of the policies and all of that requires something that is more mature than the Kubernetes native capabilities. And as I mentioned earlier, we will focus during the rest of the session on the Kubernetes audit log and how we can leverage and extract the insights that exist there for security purposes. A different view on the same challenges from the pipeline or the application delivery pipeline really tells us a story like where we really want to plug the different security components. So if you think about it from covering security gaps, you can start as early as the CI and integrating developer-oriented tools. This is a very important practice to help developers deliver secured or more secured or microservices that are following security best practices from a hardening perspective. But then again, this is something that is not covering anything related to the actual workloads and how they run in production. So I like to refer that to the pre-flight checks, just like we do like airplane departure checks. These are kind of the checks we want to have on the configuration. And once we move into the production environment, we want to have like an enforcement component, just like OPA gatekeeper. Alcide admission controller can actually help you with that. The runtime protection, whether you want to segment the traffic, monitor processes, or do advanced network security monitoring. So all of these are ways to kind of cover the Kubernetes end-to-end security challenges as a whole. So taking a step deeper into Kubernetes audit log and the Kubernetes API server, let's focus a little bit about who can access Kubernetes API server. So we named users as kind of one entity that can access the API server for read or write access. So read from that perspective would be reading resources. So for example, describing pods, or God forbids, reading secrets from the API server is one action, but deploying pods is another action that we really want to kind of identify and understand who those users and whether they can do that. We have cluster or system components that help us essentially, that help us kind of operate the cluster on one hand, but from the API server standpoint, they have a constant interactions and API invocations with the API server itself. And you will be able to see that on large clusters that are, have a high density of pods or relatively high number of automation components like controllers and Kubernetes operators, all of those components creates or introduce pressure on the API server, and the API server generates audit logs. So essentially, the Kubernetes API server audit log is an extremely verbose audit source. So the system components are another entity or set of entities that access the API server, and service accounts are pretty much cluster automation that help us to get data from the cluster outside or help us monitor. All of those components that are performing cluster automation tasks may have service accounts that are privileged to the level that they can either change things in Kubernetes, like for example, operators with CRDs that operate on those, or they can read resources from the API server. So if we try to think about what we can do with the audit log, so when it boils down to the fact that the raw audit logs are an extremely verbose and high volume data source. But on the other hand, despite the fact that we have a large number of events that record every API invocation or every change made to the system, we can really leverage this data to identify, for example, exploitation attempts on vulnerabilities, whether known or unknown, on the Kubernetes API server. We can identify stolen credentials from an SRE laptop that are being leveraged to access the cluster. We can identify stolen tokens from an in-cluster component. So there can be a scenario where there is an application breach that lands the attacker inside the cluster. And we can also leverage the audit log for compliance-based kind of attempts to understand if someone access a sensitive workload, then we must have an audit trail on that. There is a really simple way to establish policies that fire alerts to external system when those events are happening and violate those policies. Another insight that we can get from the audit log is misconfigured RBAC or violation of policies built into admission controllers. Those are often tracked by permission denied return code from the API server. And all of them are viable use cases when you operate Kubernetes clusters. So when building kind of the Kubernetes audit log processing and analysis pipeline, we have four main kind of steps. The first one is the acquisition of the data source. Luckily or unluckily, Kubernetes in the various deployment modes, whether hosted or self-hosted, we need to plug the audit log to external system. So GKE is one way of doing things, AKS is another, EKS is kind of a third option. And then we have the Kubernetes native way, which is exporting the Kubernetes audit log as webhooks. Once we acquire those logs, we can filter and transform them. Essentially, from an AI perspective, it's like building audit features and tracking down those features to determine, let's call them the interesting parts of the audit log. So for example, which users are acting against the API server or operating API calls, which IPs and semi kind of authentic identifiable information within the audit logs, what type of resources the different actors are accessing. And all of these are extremely important to build profiles, because once we have those profiles established over time and updated over time, we can really engage detection based on deviations from those profiles. So even if we have components that are deployed with God permissions in the cluster, the actual behavior of the workload is what we establish as the behavior of the entity. And if it deviates from that, that's an indication that there is an anomaly. And if we have series of anomalies, we can really leverage that in order to fire an incident event that the security team can, based on that, leverage to kind of investigate and drill down to the specific event. And naturally, once we have those events, we want to report them to external systems where the normal security tool stack is actually implemented. So this can be your SOC, it can be your Splunk, which can be part of the SOC. So really up to the implementation and the user kind of security tool stack that they use. So from what is inside this audit log perspective, we can really identify the different of the important assets. Every API invocation records the API call made to the API server. So we can really see here the operation, whether we are trying to read something or create a resource or list a resource. We can identify the namespace, the resource type, very important information about the user, so which username is being used, the principal, and which groups is he part of, and a little bit of less kind of authentic or attributes that we can rely on because they can be spoofed. These are the user agents and the source IP. So all of those kind of features inside the audit log are features that can be faked by an attacker, which means that we cannot rely on them solely in order to kind of fire an anomaly or an incident, but they are really important when it comes to building the whitelisted behavior of the system. So under the assumption that non-breached components or components that their integrity is fine and complete, they will exhibit a behavior that we can track and we can build profile and we can characterize. And an attacker would not necessarily act or follow the very same practices, which help us really kind of identify the anomalies. And the last component is pretty much API call decision. So if something is denied, then this is definitely something that we can track as part of the audit log. So some use cases that we can leverage in order to implement security controls inside Kubernetes. The very first one is really straightforward. We want to establish, and this is something that we internally do have a practice around that. If someone exits into a production pod across all of the monitored clusters, the production clusters, we are sending an alert to a Slack channel. Essentially, our production environments are gated, so there is a very limited set of users that are allowed to access the production clusters. And whenever there is an access event, like someone literally either exec into a pod or port or proxy into a pod through the API server, then this is something that we can fire an alert. And the application of this capability can help us if we are building an application that is subjected to PCI regulation, for example. The PCI regulation requires an audit trail in place of such events where someone access the system that contains sensitive, like cardholder data in this environment. So for example, build your workloads into a certain namespace, define a rule that if someone exits to a pod inside this namespace, send an alert. So this is kind of a practical way of doing things, or just an internal practice that SREs would like to kind of put in place. Any unauthorized access, so this is kind of the 403 side of the house, is something that we can identify by analyzing the audit log. Sometimes it can be because the ARBA configurations are incorrect, but sometimes it can be due to a malicious user that is trying to probe or trying to pivot inside our cluster. And it tries to make API calls that are failed because the caller doesn't have the appropriate, for example, permissions. So effectively, those events is something that we can identify from the audit log. Some can argue that you can put thresholds to fire alerts based on that, but I will say that if you place static thresholds on dynamic systems like Kubernetes, this is a practice that will fail over time. So effectively, the AI has the ability to sense and adapt those thresholds based on the behavior seen inside the cluster. When it comes to threats, either coming from human users around credential theft, or from threats that are coming from within the cluster, specifically in this example, if someone steals credentials that have API server access, we can, for example, identify if the same credentials are being accessed from different countries or different autonomous systems. This is a highly unlikely behavior that a normal user of the system will exhibit. Sometimes we can see such events if user connects to the cluster outside the VPN and all of a sudden connects to the cluster inside the VPN, and the VPN goes through a different country than, for example, or in a different ASN. And this is an example where a false detection may be fired, but the general kind of practice is that this is an event that shouldn't happen and indicates of an anomalous behavior of the system. Another example, application breach. If we have application workloads and those workloads, for example, have a vulnerability or a weakness, this is something that happens more often than we want to, of course. Then in this case, we can really identify those events pretty much because even if the component is highly privileged inside the cluster, but the normal operations of this resource is just to access a certain resource type. So for example, just accessing config maps. And all of a sudden we have a breach and the attacker would try to, for example, read secrets. Then those events will fire an anomaly within the K8s, pretty much under the notion that we don't want to have those events go unnoticed. And again, going back to square one, Kubernetes audit log is an extremely verbose and the configuration is relatively complex. So K8s really help us to kind of get security monitoring in place. And that's where K8s comes as a really valuable tool for security teams because they can really focus their attention and efforts on the important stuff. What we shouldn't use audit log for is pretty much around, for example, checking whether resources are available inside the cluster or we want to take actions on resources. We cannot implement mitigations or prevention using the audit log itself. The audit log is a near real-time detection stream of data or a subsystem that helps us to have near real-time detection. It's not something to prevent events. In order to prevent resource deployments, we need to use admission controllers. Performance monitoring is definitely the wrong way to implement using audit log. You can leverage Kubernetes metrics, and Kubernetes is instrumented with many, many good metrics that you can scrape using Prometheus or whatever tool you want to use like Datadog. But effectively, measuring performance using the Kubernetes API audit log is not the recommended way to leverage this data source. Workload level protection, so isolating application workloads or monitoring application workloads like their network activity is not something that the audit log can tell us. You need to have that for that runtime agents that monitors the behavior of the containers and the processes and their network behavior. So let's take a quick look on K8s. So let me see, I have two environments where I would like to show you the K8s. So you can see here that we do have inside this environment a timeline that tells us a story about events that are happening in the system. We can pick subsets of the timeline, and based on that, we can select specific users, and we can really drill down and investigate the behavior of what the user had done on the system. So you can see, for example, that we can see if a user created a resource. In this specific example, it's a pod, but at the very same time, we can see if there were anomalies detected on activities made by this user. So it really tells us a story in quite different way than the raw audit log. Another nice example would be around the Kubernetes policies. So we can establish rules that can help us, for example, identify exec into a pod. So you can really see here an example where I can specify, for example, the resource namespace, and I can specify here my PCI namespace. And based on that, I can create kind of a rule that will fire an alert to an external system once there is a violation of this rule. So essentially, it's a really straightforward to implement audit log, monitoring and security detection using this audit source and Alcide K8s. So going back to the slides, from an operationalization perspective, the better practice, and again, this is really kind of using the right resources for the right task. The better practice is to use or run K8s outside the monitored clusters, based on the assumption that if there is an attacker that is able to gain privileged access inside the cluster, we really don't want the attacker to circumvent or disable the security mechanisms, pretty much because they can be used to detect the attacker as well as to collect data that will help us to investigate what had happened and what attempts the attacker was trying to do inside the cluster, or which assets he was trying to, he or she were trying to achieve within our environment. So this is why we can see here that K8s will normally run outside the Kubernetes monitored cluster. Effectively, and again, this is something that revolves around building security solutions for Kubernetes. Normally, we want to integrate them into external systems, and it's really important that we can feed those external systems with the right information and the ability to kind of go back to expert systems and do the investigation using kind of first-class tools in the SOC and second tier tools that can help us do the deep drill down. So just to conclude, on the Kubernetes audit log part, this is an extremely valuable source of information for both ops and security. Taking advantage of the Kubernetes audit log and leveraging security insights and detections requires effort in plugging to the audit source and effort in building practices around extracting data, not to mention, building AI to derive insights from and detections from the audit log. Policies are not necessarily easy to get right in terms of like building your right RBAC policies. So even if you are not fully kind of hardened on the RBAC side, K8s is something, or monitoring the audit log is something that can help us understand if there is deviation from policies that are not well tuned inside the cluster. And from my perspective, the fact that we can really focus security team on unknown threats, unfolding hidden parts of Kubernetes, unfolding this black box, extremely powerful one, but definitely something that has a lot of blind spots inside of the system, is something that we can, by leveraging automation, can help security teams get from mitigation to prevention, or acknowledging that an issue is not important, is something that is extremely valuable to the efficiency of the security team. And again, there is a very wide range of security risks and threats that monitoring the audit log can help us achieve that. So our journey as a company really kind of boiled down to starting with runtime security, going and expanding to kind of understanding what we can harden and take care of as far as the configuration goes. And there are a lot of options there. And from there, moving on to Kubernetes audit log that help us really unfold all the moving parts associated with Kubernetes. And this is where kind of having all of those components as part of the Kubernetes security stack can really help both, internally in Alcide, but for our customers as well, to build services and focus on building the services rather than focus on building, homegrown security that is partially kind of fit and partially kind of have blind spots as far as operating those environments. So with that in mind, we can definitely have time for questions. You can hit Slack channel and shoot questions. And I encourage each and every one to kind of try Alcide Kubernetes security component, whether this is K8s. You can go ahead and get yourself a free account on our cloud service and experience Alcide Advisor, which is the configuration side of things, or you can use one of the open tools that we have on our GitHub. So with that in mind, I will sign off and happy to take questions from all of you. Thank you.